Right, Year 11, progress check, week 4. We've got that fluorescent flickering. That seems to have fixed it. So this is term 2, week 4. Is a multi-choice question is the first question. It says which one of these are possible for an object to have these charges. So charge can only be in multiples of the charge on an electron because that's where the charge is coming from. It's either lost or gained electrons. So the total amount of charge has to be a multiple of the charge on one electron. So that means C, which has a charge equivalent to 5 electrons, so 5 times that, and D, which has a charge equivalent to 3 times that, the charge on one electron. So C and D are the only ones. Question 2, draw a diagram of what happens if you bring a positively charged object over to a neutral one. So as this positively charged object comes in close here, the electrons that were sort of evenly spaced all over this are going to be attracted towards that, and that leaves an overall positive charge this end and a negative charge that end. Right, what happens if, what's going to happen is, are they attracted or repelled or nothing? It's going to be attracted then because you've got a positive and a negative. And what happens if you touch them? Some of those negative charges will actually jump over onto here. Right, and then if you pull them apart, that means that this will have an overall positive charge because it's lost some of its electrons. So that's pretty straightforward too. All right, this one. Look at this drawing. Can you believe I failed art in grade 8? Look at that book on a shelf. Got a little prop and everything. Righto. The weight is just Fw equals mg. So the mass was 0.8 kgs. Acceleration due to gravity is 9.8, so you just multiply them together, 7.84 newtons. And because it's a vector quantity, we should have a direction. So the direction would be down. Right. The normal force is the force, it's always at right angles to the surface between the two objects, and it's the opposite of the weight. Right, it should actually be written Fw equals negative Fn, and that negative signifies that the direction is the opposite way. So if we're going to say that positive is down in this case, so positive's down, so this will be positive. The normal force is going upwards, so it will be negative 7.84 newtons. All right. Next one. Oh, this is the one where it says, can the amount of force required be different depending on how long the time is that it takes to get this acceleration? So acceleration is delta V, or change in velocity over time. Right? The mass is going to stay the same. So force equals mass times acceleration. Mass is staying the same, so our force is only related really to the acceleration. So the question is, can the acceleration, where it goes from 0 to 30, does it always have to be bigger than going from 0 to 10? And no, because it depends on this time. Right? So depending on the time that's involved, the acceleration could be larger or smaller. So can F2, this one here, the force that produces this acceleration from 0 to 10, because you have your final minus your initial, be greater than F1, where it goes from 0 to 30? And yes, it can if that t is small. Right, so time affects the force required. So yes, you can have that happen.